Okay, we're gonna model actually a column that the link is simply supported in both edge of the column, subjected to applied load as a compressed column. The length of the column is 4 meters. The height, the cross section is a rectangular, sorry, a square cross section with dimension of 150 millimeter, a thickness 10 millimeter. Uh, you can reduce the thickness into 5 maybe. If we make it 5 millimeter, it could possible to be done. So let's do it 5 millimeter for a moment. And the elastic modulus is this elastic modulus, and also in megapascal, which is Newton per millimeter square, I will use a grade of 355, where the yield modulo elastic yield stress is 355 and megapascal. And finally, the length is the imperfection. I would choose the imperfection as the length over 1000. Okay, to model, we will go to part, and then I will choose shell and extrusion, and then continue. I will go into this rectangular. I will click in the middle somewhere 0 0, and in the outside anywhere here. And then I need to adjust the dimension. I will go to this dimension, and then I will click on this dimension, go back and click out 150 millimeter, and then enter. Also, I need the dimension of this dimension, the horizontal line. You click on the line, you go back, I go up, and you click out. You add the dimension, which is 150 millimeter, and enter. Let's zoom out a little. Let's zoom out a little bit by using your mouse. Scroll the rule, and then you get that section. And then you press on that cancel procedure, and say done. I will choose the length as we said 4000. So that's our first 1000 and done. Now let's save the model. I will go to save model as the save model by database, and then I will go into C, working file. I need to, for example, save it in Abacus file. I will call it, for example, buckling of a square column. Buckling of square column, and then OK. Now I need to set directory. I will go to file and set directory. I will choose a directory not in C. In the file I save the model in. I will go to my model and then working file. I will save everything in Abacus files, and then you said OK. And then you see this save directory in that directory here, and you said OK. Here in this situation, everything will be saved in one model in one file. And then you go to property. You need to assign a material. You click material manager, and you go to create, and then you use S355, I will name it, the grade of steel, and then mechanical elasticity, and elastic. The Young modulus 210123, and the Poisson ratio is 0.3. Now the plastic property is basically you go to mechanical, plasticity, and plastic, and the yield stress will be 355, and the plastic strength 0, of course, because it has a perfect plastic model. And then you said OK. Now once we finish, we will go to section manager. I will go to create, and keep the section like call it cross section, and it is a shell element, homogeneous material, and continue. And let's make the value of 5 millimeter as we discussed, and you said OK. Dismiss. Now let's assign into this model. You go into assign manager, you go to create, you make a window, and you click all the model, and you said done. And this is cross section material 355, and you said done. and then done here and dismiss. Let's save it. And now let's go into assembly. Let's break the model. You go to click on assembly, you go independent, and then you said okay. I choose independent because I want to mesh on the assembly and said okay. Now you go into step. I will conduct firstly a buckling analysis. I will go into step manager, create, and I will go into linear perturbation. You go to buckle and you said continue. I will choose 5 buckling modes. I will increase the number of iterations to 5 to 300 and I keep everything as it is in order to generate a buckling mode and buckling load, and then okay, dismiss. You go to interaction. In the interaction I would like to create a point load in the middle of the cross section. To do so, I will go to XYZ datum, click on this and keep clicking and you choose the second option. Now you're gonna click for example on this point and you want to say that I want point distance from that point by about 150 over 2, which is 75 in the middle. So it's a 75 and said okay. Similarly, you're gonna rotate, we click there and you rotate the model around here. You will zoom it in and then you click there, the same thing, and you say 75. Now we've done this datum point. I will actually down escape to finish the auction. RP was a reference point. I will click on the reference point. I will make one in the datum point here, and I will generate another one in the datum point here. Okay, now cancel the procedure over there. I click on the X. Then you go to assign all the cross section points into one point, which is the reference point. So to do so, I will go to constraint manager and then create. I will call it at the top, create as a rigid body, and then you continue. I will click on the tie and you click on the edit selection, then and you click on the edges. You click on the edge and you keep clicking shift in your keyboard. Click there, click there, click there, and done. And then you click on the point, you click there, and you said done. Okay. Now bottom. The bottom one. You click rigid body, you continue, and you click on a tie, you click here in edit selection, you keep shift, click and shift on the keyboard, you click here, here, edge here, and the edge here, say done. And then you click on a point, which is a reference point, and you said okay. So in this situation, all this point on the boundary condition will actually follow one reference point. Dismiss it. Now you go into load. You go into create boundary condition manager. I'll create, let's call the top boundary condition. I will make sure it is initial step. Take the second option and you continue. You don't need to take a boundary condition on the edge now in a reference point that you created. So this reference point you need to create reference point and a rigid body constraint, and then done. Now I want actually, if you notice that is X, Y, and Z, I want a pin support, so it must be U1, U2, U3. However, because I want to apply a load in that direction, therefore this has to be free. You said okay. And then go create, and now bottom side, and displacement, rotation, and continue. And then you go into this boundary here, the RP2, you click on the RP2 and you say done. You click one U1, U2, U3, and also to give the pin support, and also I want not allow rotation around the direction, and then you said okay. So that's all done. Now you go to load, and not to apply load, you go to load, you go create, and you make sure you use actually step 1. Use a concentrated load and you apply on the top, and then you continue, you apply on the top, and then you say done, and you need to apply load in Z direction, and therefore will be -1, for example. We keep it -1 as a load -1. So because you're gonna use a buckling load, so the buckling load or the buckling mode will be adjusted. Then dismiss. You go to mesh. Now I will do the mesh. I will click on the mesh. I will choose 20 millimeter as a mesh, for example, which should be enough. And then you said that okay. And you click on the mesh instance and you said yes. And now click on element type and you click on the model and you say done. And for example, I don't want it to reduce integration. Make sure it is S4 element. And then you said okay. And it's done. Now before I finish, I need to save. And finally, I need to write a small code in order to create a buckling mode and a dot file model in order to do a buckling nonlinear analysis and use it for imperfection. This. So you go to file, sorry, you go to model, edit keyword, and you call model 2. You go to the end. You click there and you enter and you put a star node file enter U. So here what's gonna happen is basically the abacus will generate a dot file model, a dot file, a file which is extension of that file is dot file, and this dot file will be read by abacus later in a linear analysis, and this dot file usually include include the display, the node number and displacement associated with. I said okay, and then we go into job. You click on a job, create. Let's call it buckling, for example. Call it buckling, and you said continue, and said okay, and you submit. You should follow, and this is okay. You should follow the steps by step in order to create a correct buckling load, buckling analysis. So it is submitted for analysis. If you read down is input successful. I think it's gonna have some conversion problem. Thing is stuck a bit. It's stuck. I think I need to close it and get back again. Okay, I need to close it. And then I'm gonna open it again. It's not open. The abacus. Okay. Now it's stuck, so I need to reopen it again. So I'll go to model again. Okay. Click there. Working. And it is abacus file. Get recovery. Yes, and then recover. Go job. Okay, it's completed. And you click. Oh, okay, here we go. So this buckling is a buckling. It's a global buckling. That's what I'm looking for. Now, get back again. So what you have to do, need to do buckling. That's again, let's go back to discuss. So buckling load is 1.44 times 10 power 6. This is OP first mode, second mode, third mode, fourth mode, and fifth mode. So we're gonna use the first mode or the global buckling. Go now into I need to uh, perform nonlinear analysis. I will go to model 1, copy model, call it model 2. Okay. Now in a model 2, we're gonna work on a model 2 now. So be careful what we have to do. In model 2, go to model, edit keyword, and go to model 2. Go down, 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 and delete these two lines. That's the first step you have to do. And then you go up. Before step, go enter. And actually, you need to copy. You need to write this code. This for imperfection. Copy, paste. Now, just to let you know, this is a file buckling, and the value you need to change is this value with imperfection size. Now, what we said, imperfection chosen was L over 1000, so it's 4000 over 1000 4 millimeter. So I would write to down here 4 millimeter. It's just a value as a 4 millimeter, and you said okay. Now you go into step, you replace it. You go to general static, and then you just click it on, and do incrementation 0.01, make it 1000 or 10,000. This is make it 0.5, and this is write it as of 10, and then it's okay. Dismiss. You go into load, you go to that load you create, and delete it. You don't want it now. I will apply displacement control here. So you go to loading boundary condition manager, you go to create, and this is loading. You get displacement, make this is step 1, continue. You click in the node here, done, and you put, for example, minus 50 millimeter as displacement applied down. 50 millimeter. I will make it 70 millimeter. Said okay. So you need to apply 70 millimeter to see. And you go now to that's done, all done, job. You go to create job, create test, for example, and model 2, continue, make sure this model 2, and okay, and now you can submit and see how it goes. Aborted, let's see what's aborted. When it, no, sorry, monitor, it says mode number must be positive integer. Okay, dismiss it. Go to model again, you go to edit keyword, model 2, and then you go down, down, down to this code you draw. By the end of 1 here, you make a backspace in your keyboard, and then you enter again, and you said okay, and submit again. It seems working. Let me make sure that is running. Dismiss. Let's check the result. Ah, good. This is going well. Let's see now. Let me go see result. Let me get the result. You see it's buckle. Gonna take some time. As you see, it is buckle. It seems it's fail. We'll wait a little bit more. Okay, let's get the results. Okay, it is buckle. So I get more time. Now for the time being, I think on this way, I think it's buckled. So let's kill the model just for the time. And then I will get the result. Make sure this is activated and you click there. And then you go to tools, data XY manager, go create ODB file output, continue, go unique node, and then RF in Z direction, and you are in Z direction as well. Now with the point I need, I will go to node set. I need to click in the highlight, so I need to look for the point. Here we go, it's this point I'm looking for. So it's set 7. Save. This is the load. Double click on the load and you copy all this. Copy. You go to Excel. Paste. So this is a load. Now this is negative, so divided by minus 1000, because 1000 is to convert divide by to convert into kilonewton, and minus to make it positive. Copy, paste this. Okay, just delete it. Okay, and then you go into U2, which is this displacement. Copy, and this I need positive displacement, so multiply by minus 1. Copy, paste. So I would like to take this displacement here as the x-axis. So I will take all that, insert this, and let's take this one. Good. So that is it working now. It's working now, so it just goes up and goes down. Maybe we're gonna use actually Riks methods. For a moment now we use general static, and that is the ultimate load. We may need to use a Riks method for this case. Now, if you face a problem that it doesn't converge at all, and it's just to go to the ultimate load doesn't go down, so what you can do, delete this. The only thing you need to do is you go into step, you go to step, you replace it by Riks method, sorry, and you set this on. Sorry, this is on incrementation 0.01, and here you said 100 or 100, it should be enough, or 1000, and this is 0, and this is 15, and then you said okay, and dismiss, and you can go to load, you go to this fog boundary condition, you change it into 1 millimeter, should be enough, because Riks method will sort it out and dismiss, and now you can go and run the model again, test with Riks methods, and you said okay, okay, and you submit. So if you want to do it with Riks method. Now in this case actually this works because it doesn't go back and then buckle. It's basically it's still we can use a displacement general static. My advice to you is if it doesn't, you can directly work out using the Riks method if you want to continue. So this Riks method will generate the whole nonlinear analysis. Goes up linear and then buckle to generate the whole linear analysis. For this case is working without Riks method. Now the ultimate load is here, which is about 886.72 kilonewton. So that's ultimate load, and you see Riks method now it's working, but I'm not gonna actually conduct any result from it. And then yeah, I'm gonna clear the model just to show you how to do Riks method. Make sure when you finish the model or nearly kill the model that all the area about to be all plastic. So here plastic is basically red. So when it become red mean that it's yield. So all this area yield. Okay. So not necessarily to continue forever Riks method. You just click it when it is suitable. Thank you very much for listening.